Okay. Anuna, please let me start again. Welcome to the GFC school, and today our discussing point is circular motion. You can see this video, and from this video, you may understand what is actually circular motion. And last day, I said gravitational field, and in that lecture, you could see Earth was orbiting around the sun. That was also circular motion, and for understanding the circular motion you have to know some quantities, and among those quantities velocity on. Okay, and you can see from this video this ball is orbiting by velocity by velocity v. Okay, it's actually a practical example, and this is another practical example, and from this example you may understand actually what is a circular motion. Look, you ever seen this?
Yes.
Hello. Okay, here we'll learn some words like period. Okay, and we'll learn about frequency. We'll learn angular velocity or angular frequency. This word
Yes.
we'll learn uh, from this chapter. Okay. Hello.
Yes, sir.
Hello.
Hello.
Okay. Have you understood from this figure, from this video?
Yes, sir. A bit.
Okay. Okay, fine. Now it's clear. Actually, just now I've not got the sound from the mobile. That's why I couldn't understand. Anyway, uh, I guess you are now hearing me clearly. Okay.
Yes.
Now I also got your point and got your sound anyway, but previously I didn't get any sound because my connection was wrong. Anyway, just now I've shown you this video, and from this video you may understand what's the types of motion. Okay, this is the circular motion, and from this video you have seen this circular path and where a ball was orbiting. Okay, moreover let me show this ball. Okay, here here look at this point. This is velocity of this ball, and by this velocity is orbiting, centering this point, and such type of motion we called circular motion. For understanding
Yes.
the circular motion, we have to know the features of velocity. Do you know, is this okay, is velocity here constant? Could you tell me?
No, sir.
No, because because why? Velocity is on constant. Okay, let me describe this. And if I start this video, then you may understand. Okay, fine. Look, this velocity at this point here, at this point velocity v. Okay, fine. Okay, here the direction of velocity along this,
Changes.
and okay, now the direction of the velocity another direction. Okay, this velocity direction along this direction, and
Yes.
here velocity is upward. Just before, velocity direction was downward, now upward. That means direction is changing. Direction is changing. And you know, velocity is a vector quantity. Am I right?
Yes.
Okay, fine. Since velocity is a vector quantity, it doesn't remain constant because its direction is changing. Okay, fine. The amount of velocity remains constant, but direction is changing. Due to the change of direction of velocity, so velocity here not constant. Understand? Here
Yes.
velocity is not constant because direction is changing, but magnitude of the velocity same, but direction is changing. That's why what I've said. Velocity is not constant, but speed here constant. Speed constant.
Yes.
You know, speed doesn't depend on direction.
No.
Speed doesn't depend on direction, but velocity depends on direction. Since the direction of the velocity is changing, that's why here velocity is not constant. Due to the change of velocity, there is a acceleration. Understand?
Yes. Yes.
Since velocity is changing, that's why we are getting acceleration.
Acceleration.
Here, where where is the acceleration acting? Acceleration acting towards the center along this direction. Okay, and also we say centripetal force. Have you understood what I've said?
Yes.
Centripetal force means it acts towards the center.
Center.
This sign. Okay, let me draw this. This is centripetal force, and it is acting along this direction. Understand? Radius. Now, actually, okay. This centripetal force equation. This, have you ever seen this equation? Here
Uh,
m is the mass of the ball, v is the velocity
Velocity.
of the ball, and r is the radius of the circle. Am I right?
Yes.
Okay, fine. That means you've got clear concept. You've got clear concept centrifugal
Yes.
force equation. Now,
Yes.
you know from the Newton second law. What is the Newton second law? You know, F equals
Force is directly proportional to
Okay, for
Moment.
F equal right, you right. F equal ma. Ma here
Yes.
mass of this object, and here is the acceleration of the oxygen. I don't know. Have you got the clear concept from this video?
Yes, sir.
I have shown you the animation and video. From the video, I am trying to feel what is circular motion practically, and I have said the formula of centrifugal force, and centrifugal force means it is acting towards the center, towards the center, and here uniform acceleration, here actually remaining uniform acceleration, and due to this acceleration due to the force acceleration is created. Am I right?
Yes, sir.
Due to the force acceleration is
Acceleration.
created, and moreover this ball is orbiting due to the force. That force is centripetal force, this force, and it's actually balanced force. What do you mean by balanced force? It is balanced force. Am I right?
Yes, sir.
Without having balanced force, this ball doesn't orbit fairly smoothly. Am I right?
Yes.
Since ball is orbiting fairly, that means there is acting a balanced force. Okay,
Yes.
fine. One force name is centripetal force. Other force name is centrifugal force. Centrifugal force, and this force and centripetal force equal. Do you believe? This force and
Yes, sir.
this force, centrifugal force means outward of the circle, a centripetal force inward of the circle, which is acting towards the center. This is centripetal force, and by this centripetal force you can rotate this ball. Okay, and from uh, pro, from this two figure, this is FC, another is F. This equal, and
Yes.
we can write MA equal MB square R. MM cancelled. That means AC means
So V square by R.
sorry, AC means AC means
V square by R.
V square by R. V here
By R.
V
By R.
by R. V here linear velocity. Linear velocity. Am I right?
Yes.
Okay, fine. And R here, what is R?
Radius.
Radius. Radius. Okay, fine. And here acceleration. What is acceleration? Sorry, do you mean by A?
Acceleration.
Okay, fine. Acceleration direction. Which direction?
It's towards the center.
Good. That's why C. Am I? Is it clear?
Yes.
Acceleration. 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 Okay, so we've got a linear velocity, identification, radius, acceleration towards the center. That means if question gives you linear velocity v, radius r of any circular motion, then you can find out the acceleration. Am I right?
Yes.
Okay, fine. If you know if you know any circular paths and the linear velocity of the object v and the mass of the object and radius of the circular path, then you can find out this. What is this? You can find out centripetal force.
4.
If you know the velocity, mass of this orbiting object and radius of the circle, then you can find out the centripetal force. Is it clear?
Yes. Yes, sir.
So now we have to understand this quantity. We have to feel actually practical application of circular motion. This is the practical example from where we can understand, we can feel circular motion.
Motion.
This is practical example. Okay, let me show this. Did you know that amusement, this is right, this word amusement park, okay, amusement park is also a huge physics classroom. Amusement, if you go to amusement, then you could see a lot of practical examples of a circular motion.
Yes.
Okay, circular this picture, this animation, and here we have to know some quantities related to the circular motion. Which are those? Look, those are period, okay, and angular frequency, we will learn frequency, okay, and uniform circular motion, that means we will learn period formula, frequency formula, and angular velocity or angular frequency formula. We will learn.
Yeah. Yes, sir.
And we will learn the definition, okay. Moreover, we will learn mathematical problem. Along with, we will learn various past papers based technical mathematics, okay, and I am trying to make you understand the fundamental topics related to the circular motion, okay. Now Hello. Mm, okay. Now, circular motion related some quantities we are going to learn, and you could see this picture in 2025 exam question paper. Okay, this picture you could see, and this is actually a picture of circular motion. Circular motion. It's a wheel, and it's a large cog. Okay, large cog, and it's a small cog, and actually this is actually circular motion based object. Okay, that is bicycle. It is actually bicycle, and bicycle, and here okay, look at this picture. It also a picture of a circular motion, and actually it's a wheel of a rickshaw or bicycle. Okay,
Yes.
rickshaw, bicycle, spoke, axle, a, and you could see this picture in 2025 exam question paper. Okay, you could see, and later we'll solve this question related some problem. Okay, and okay, and from this car you may understand practically what is angular velocity. Here look, from this car you may understand. In my last video I showed you amusement park some devices. Okay, now from the car you may understand angular velocity. This is angular velocity. This is angular velocity. Angular velocity like this way. It's a circular way. Okay. This angular velocity. And angular velocity symbol. Angular velocity symbol omega. It is omega. By omega,
Yes, sir.
we mean angular velocity, angular frequency by omega. Now, what is this? What is this?
Velocity.
This is this is this is this is linear velocity. Okay, and linear velocity means linear, straight line. Okay. Linear velocity, linear velocity, linear velocity, linear velocity, linear velocity, linear velocity like this way. This is linear velocity, and our point is angular velocity. Our discussing point is angular velocity. Angular velocity in this circular way. This circular way. This,
Yes.
it is actually in the wheel. That is a angular velocity,
Yes.
and we are going to understand that velocity. And here I have shown you angular velocity by the example of car. This is the angular velocity. Again I mention, again I show you, this is angular velocity, that is in this circular path, that is in the wheel, we get the angular velocity omega. This is the, this symbol name is omega, and by omega we mean angular velocity. And here this is linear velocity, and linear velocity equal r omega r. Try to remember this formula. V equal r omega. Okay, this formula you have to remember. If question gives you radius and angular velocity, then you can find out the linear velocity. Linear velocity means this car by the angular velocity of wheel is going forward along this direction. This is the linear velocity. Okay, that means linear velocity and angular velocity correlated, and by this formula V equal to r omega, we may find out linear velocity of this car. If question gives you the radius of this car here, no, this is radius of the car, and omega is the velocity of this wheel. Okay, and by rotating or by orbiting the car goes forward by velocity v. V equals r omega, and here you can see the angular velocity omega, and that is the direction of rotation. That means along this direction something is rotating, and then we'll get omega. And actually omega is a velocity, that means it's a vector quantity. Since it's vector quantity, it has direction, and by this rule or by this right hand rule. By right hand rule, we could show the direction of the angular velocity. Nice. Oof. How wonderfully I am presenting. I am mentioning. Okay, I am describing here. This is omega. It's the angular velocity. It's the direction of angular velocity. How have we found this? We found this by right hand rule. If we thumbs up this way, the direction of the hello.
Yes, sir.
Okay, I can't hear sound actually. Okay, uh, uh, I have shown you the direction of angular velocity by the right hand rule. This right hand rule. If we thumbs up our four fingers towards the direction of the motion, is the direction of the motion, then our thumb, this our thumb will show the direction of the omega. It is right hand rule. This right hand rule. Since you know your right hand, and if you place your four fingers along the direction of the motion, then this thumb will indicate the direction of the angular velocity. This is the angular velocity direction. Okay, let me show you another slide. We'll learn the angular displacement, right? Angular displacement. Let me describe this. Let me explain this. What is angular displacement? Since we are learning circular motion, we are learning circular motion. Okay, we are learning circular motion. That means displacement is angular. That means displacement will be angle. And just now I have shown you a video. A ball was orbiting, centering a point. So this ball is at this point. After some time, it may be go here. It may come here at this point. And then we could join this line. This, and what will be the angular displacement? Angular displacement will be this. This is the angular displacement. That means angle.
Yes.
Look, this ball was at this point. After some time, it has come at this point. That means it has completed. Completed this path. This is arc of the circle, and it is actually not angular displacement. Angular displacement this.
The angle.
That means angle. Oh no, Are you switching off my video?
Yes,
Sometimes I
sir.
can't see you. Why? Anyway, it's your icon. Now, oh, now I am trying to make you understand what is angular velocity. Now, sorry, angular displacement. Angular displacement, actually, what is the angular displacement? Angular displacement means angle. Okay, how much angle
Yes.
the object is completed, how much angle. Okay, now
Yes.
fine, we can measure this angle, this angular displacement by this formula. S equal to, theta equal to s upon r. By this formula, we may find out the angular displacement. And here theta equal to s upon r. Okay, and what do you mean by s? What do you mean by r?
Arc length.
R means r means
Radius.
and s means
Arc length.
এখানে sound আসে না। Hello.
Yes, sir. Can you hear me?
Okay. Okay, fine. S means what is this?
Arc length. Arc length.
Good. Oh. In the mathematics, you could see this topic. Okay,
Yes.
theta equal to theta equals oh my gosh, is theta equals s upon t. So, oh no, we are finding out the angular. We are finding out the angular displacement. That means s equal, sorry, theta equal s upon t. Here t is, sorry, r. This is r. Am I right?
Yeah. Yes.
This is r. Okay, theta equal s r. R here radius of the circle, and s is what is this? Arc.
Yes.
Arc length. You said nice. Arc length. That means if question gives you is, that means arc length and radius of any circular path, then you could find out the
Angular displacement.
angular displacement. Or if question gives you angular displacement and radius, then you can find out
Arc length.
arc length. Okay. And one revolution, this is a suppose this object at first at this point, and after certain it has completed the path and has come at this point, then we would say one revolution. Am I right?
Yes.
Okay, fine. And one revolution means angular displacement. How much?
Yes.
How much?
360 degrees.
Good. Oh, you're intelligent. Nice. Okay, that means we've learned one revolution means 360 360 degree, and or you
Yes.
could say 2 pi. 2 pi means 2 pi means
360 degrees.
radian. It's not degree. At first it said 360. It is degree unit. Here radian unit. Understand?
Yes.
Here radian unit. Okay. Now, uh, now look this radian. We are going to learn radian. What do you mean by radian? What do I mean radian? What do you mean by radian? Actually, last day I recorded. there's there's a this written still remains here. Anyway, uh, radian. Have you heard the name of this word?
Yes. Yes, sir.
Okay, fine. For understanding the radian, you have to take this picture, and from this picture, you may understand radian clearly. You try to understand from this figure. What does it mean? What does it mean? From this figure, what can you say?
Uh, the arc length is equal to the radius.
Okay, fine. That means you know this. That is radian. And in 2025, one question came like this way. Okay. No. Directly in the definition section said define radian. Okay. In 2025, radian. What do you mean by radian? Now, this is mathematics, and complete circle. Complete circle means 2 pi r. Do you understand this? 2 pi r.
Yes.
What's the name 2 pi r?
Uh, that's the circumference.
Good. Circumference. Okay, dividing this by r, we'll get 2 pi divided by r. We'll get 2 pi.
Yes.
And angle in radian of this full circle. This angle is for full circle, and from this you can convert any angle from degrees to radian by multiplying pi upon 180. Understand? If you try to convert from degrees to radian, then you just multiply the degree point with this pi upon 180. I guess you know this from the mathematics subject.
Yes.
And if you try to convert from radian to degrees, then you will multiply 180 upon pi. Understand? From radians to degree. Understand? I don't know.
Yes, sir.
From radian to degrees, if you try to convert, then you have to multiply
Yes, sir.
180
180 by pi.
180 upon pi. Suppose from radian to degree, okay, 2 pi, this is radian. How could you convert this into degree? How just multiply
180 by 2. 180 by pi.
180 over pi. This pi cancel. That means how much?
360 degrees.
360 degrees. Okay. So you can convert from radian to degrees. You have to practice sometime. Anyway, if I give you uh, 3 pi, how could you convert this? If the angular displacement 3 pi, how can you convert this into degrees?
You multiply it with 180 by pi.
180 pi. Pi cancel. That is this multiply. Okay, good. This is actually mathematics, and I'm not interested to show this. I'm not interested, even though I have shown you the conversion from degrees to radian and radians to degrees. When you convert from degree to radians, then you will multiply pi upon 180. Okay. Now okay, fine. I have said angular displacement in my previous slide, and it's a definition. Yeah, angular displacement is the angle turned through by an object in any given direction in radians. That means angular displacement, this is angle turned through by an object. Then there's R. I said this anyway. Now, angular speed. Can you say me? Could you say me angular speed? Have you any notion?
Yes, sir.
Angular speed. Could you tell me? Anyway, you just tell me what is speed. Just tell me speed. What is speed?
Speed is a distance over time.
Distance over time. The distance means this is distance over time. You know this speed.
Yes.
Okay, fine. But here we are learning circular motion. That's why here what would be d?
The angular displacement.
Good, excellent. Just theta upon d. Could you tell this? Could you say this? The angular speed theta upon t.
Yes.
Okay. That means you got this concept from the previous chapter. That is first year, AS level.
Yes.
You've understood this equation from your AS level. Am I right?
Yes.
Now, angular speed and angular speed. We use for angular speed the symbol omega. Okay, I said angular velocity, angular speed, angular frequency. I said, am I right?
Yes.
At first I said in the video section, angular velocity, angular frequency. Now here I said as angular speed, same meaning, but you have to define in different way. Angle an object moving through a per unit time. Just now I have shown omega equal theta upon t. This is an angle. An object moves through per unit time. It can be found by dividing the object's linear speed. Okay, fine. This is another topic and another point. And you can find dividing the object's linear speed by the radius. That is actually omega equal to by radius. This is radius and v. If we divide v by the radius of the circular path, then we will get angular speed. So
Yes, sir.
the question gives you a linear velocity. This is linear velocity, right? Let me write here. What does each symbol mean? Here v means velocity, but what's the type of the velocity? Linear velocity, understand? And
Yes.
linear velocity, you understand, I know. So this is linear velocity. Velocity. Okay. And here oh God, pink. This is radius of the circular path. Am I right?
Yes.
Okay. You've got a linear velocity and here, what does it mean? Omega means I don't know. Omega means
The angular velocity, sir.
velocity, not speed.
Yes.
You could say speed. You could say velocity. You could say angular frequency. What do you want to say? What do you want to say?
Yes,
Angular
sir.
speed. Which word you wanna say? Angular speed, angular velocity, angular frequency.
So velocity. Velocity.
Velocity. Okay, fine. Now, omega equal v upon r. I showed this, and look here, omega means change of angular displacement per unit time. Am I right?
Yes.
Look, on a note, this is circular path, and is a total angular displacement. How much? How much? Total angular displacement
2 pi.
2 pi. Okay, and 2 pi. And for completing this 2 pi, how much time needed? How much time needed? How much time needed? How much time? That is called period. That is called
Time period.
T. Okay,
Yes.
period, time for completing on revolution, or for completing 2 pi angular displacement, the required time is called period. Understand?
Yes.
You may get this point in wave. Oh, but in AS level, you could see this. You could hear period. Am I right?
Yes.
AS in wave section, you could see this period. Okay, and it also omega. This also omega. Understand? Omega
Yes.
equals 2 pi upon t, and this this uh, this equation you could say such way, but through t time completed 2 pi angular displacement. And you know the definition, uh, per unit time we calculate velocity, speed per unit time. That means here by 1 unit time, how much angular distance it has completed? 2 pi upon t. Understand? This is the angular velocity. Is it clear to you?
Yes, sir.
Another point, now try to understand here, 2 pi upon t, and f equal 1 upon t. What is f? What is f? Do you know?
Yes, sir.
What is f? F here, what is it?
A
F,
frequency.
frequency. Nice. Here frequency means revolution. Am I right? Suppose this ball has started its journey from this point, and after certainly has come back to this point. This on revolution. Am I right? On rotation or on revolution? I don't know. Any question?
Yes. Yes, sir.
Any question?
No, sir.
But your hands up now. Hands down, please.
Yes.
Hands down, please. Now, uh, f equal 1 upon t. That means, if question gives you the linear velocity v and radius r of any kt question, then you can find out angular speed, angular velocity, angular frequency. Am I right? Could you,
Yes.
could you find out the angular speed? If question gives you linear velocity v and radius of the circular path, then you can find out the omega,
Angular speed.
angular speed. And if question gives you the period of time period, then the t, Could you find out the angular speed?
Yes. Yes, sir.
Just by this formula. By this formula. Okay, let me draw another place. Omega 2 pi upon t. But you have to understand the key equation or a step anyway. And if question gives you the frequency, could you find out the angular velocity? Yes,
Yes.
indeed. You could find out that by which formula? Omega equal 2 pi f. Nice. And okay. Okay, you can calculate an object linear speed by finding the product of the angular speed and radius. Okay, fine. You could find out the okay, nice. You could find out the linear velocity. How could you find out the linear velocity? By this formula. Okay, v equal
Yes.
omega upon r. Actually, it's very important. In most question, we could see such way access to find out the linear velocity. Okay, linear speed. Question asks us most of time linear speed. At first, I showed you a slide related to bicycle wheel. In that question in 2025 asked to find out the linear velocity of the wheel. Okay, and then I used this formula, and later you will see that creative question solution, first wave solution. Okay, now this picture I showed you in previous section, same picture, and by this picture I am trying to make you understand what is actually angular speed and linear speed, and by the violet sign we are meaning linear velocity, and by yellow sign we are meaning the angular speed. Okay, and this large figure, this big figure, from this figure, from this picture, you may understand clearly. This is the yellow sign. Okay, this is it, and this is the action V. Is it clear? On or no?
Yes, sir. Clear.
Okay, fine. Angular density practical problem. Okay, mathematics on mathematics. Look, on mathematics has said to find out the angular velocity. And radius this bus travels at 10 meter per second. That means bus travel means linear velocity. This 10 meter linear velocity, and this is radius. That means question has asked us to find out the angular velocity. Angular velocity means omega, right? And we know v equal r omega. Am I right? We know this.
Yes.
Let me do this. V equal, we know. Why are we using this formula? Because in the question we can see angular velocity we have to find out. And the question gives us the radius of the bus tire, and tire and the bus travels 10 meter per second linear speed, linear, then so we can use this formula.
Yes.
Now we have to do algebra. What, what is the algebra?
20, sir. 10 by 0.5.
20 upon same mathematics you will get in the creative question, first paper question. Am I right?
Yes.
Same. By this formula, you have to solve past papers. Okay, and for doing those question, you have to actually know the basic, and I'm showing those basic step by step, slide by slide. Okay. Moreover, I am explaining writing by my MacBook with the help of pen tab. Okay, pen tab. Do you know pen tab? Have you?
Yes, sir.
Do, do you have this? Can you see me?
Yes, I can see you.
Do you have this?
No, sir.
You have to buy this. Okay. You
Okay, sir.
tell your mom, please buy a pen tab for me, because I'll say you to write down something on the screen. If I ask you any question, and for giving the answer, you will write that on the screen by this pen tab. Okay. So it's
Okay.
necessary for writing something. Say, I'm writing something. How? Will I use mouse? Not. I am using pen tab. By pen tab I can write so friendly, easily.
Yes, sir.
Okay. You may need this. If you be interested in online class, until if you enjoy online class, you should have this.
Yes, sir.
Because frequently I may ask you to do this math, to write this definition. This is the second day class, that's why I am not asking you a lot of question. And after 15 days or 30 days, I could say, please write on this screen.
Yes, sir.
Values application. So, what's the formula? Formula. Uh, our formula this. Our formula is this, and our formula is this. And, we have done algebra. Model to build. And, we have put the value of dr, and we have calculated by the calculator. Then we have got the 20 radian per second. Listen, 20 radian per second. You have to be serious this unit. You have to be serious about the unit. Without writing unit, you can't get full marks. Am I right?
Yes, sir.
Okay. Now, so you have to remember the unit. Not only you have to remember formula, but also you have to remember unit. You have to understand why here radian, why here second. You have to think, because we know omega means angular displacement.
Yes.
This is
Yes.
angular displacement, and time. I am using various color. Is it enjoyable? Hello.
Yes, sir.
I am using different colors. Now angular velocity you can find out theta upon t. By this formula I can find out theta upon t. Theta means angular displacement, t means time, and here a car of radius 20 inches rotates at 8 revolutions per second in the highway. Per second how many revolutions? How many?
8 revolution.
8 revolution. 8 revolution means per revolution 2 pi. Since 8 revolution, so total
Times 8.
times 8, that means 16 pi. Am I right? This
Yes.
is the angular displacement, and question said, question per second, and we know omega equal theta upon t. Here we got theta 16 pi, and question said this 16 pi angular displacement has completed by per second. That means here time 1 second. Am I right?
Yes.
So 16 pi radian per
Second.
second. Okay. Try to remember this unit. Same power I have used here again and again, or again and again. Try to remember this. Angular velocity, it's still angular velocity. Now angular acceleration. Have you heard the name of this angular acceleration? You know, from S level, velocity, acceleration. Do you know the definition of acceleration from S level? What do you mean? Or O level?
Change in velocity over time.
Velocity over time. You know, from S or O level. Velocity over time. Okay, time.
Yes.
Time t. Okay, this is acceleration. From this formula, you will say the definition of angular acceleration. Time, same. Here, look, here, this is linear velocity. But will you use here linear velocity?
No, sir.
No, we'll just use
Angular velocity.
angular velocity, angular velocity omega, and time t. That means acceleration. And you have got this point from this section. Am I right?
Yes.
From your S level concept, you have given this definition and this equations explanation. Omega upon t. Time same, time, but here since it's an angular acceleration, that's why we have to use angular velocity. So if you can remember this section, you could use this section. We could say freely this is this. Okay. Now centripetal force, I showed this or said this in my video section. In my video section, I showed you centripetal force. Again, I say centripetal force and Will I say again? Thumbstick.
No, sir, but I understand.
You understand? But I wanna repeat this. Will I repeat?
Okay, sir.
Okay. Yeah. F means force, and this force actually. What do you mean by this force? This force. This force. This force
It's towards the
centripetal.
center.
Centripetal force. And
Yes,
this force towards the center. Towards the center.
center.
Are you changing the picture? Are you changing the picture? Are you
No,
tweaking
sir.
anywhere?
No, sir.
But the picture is changing frequently. Why? Are you doing anything by your hand?
I didn't do anything.
You don't do anything, but there is blinkering. That is moving from small to big to small. Right. Anyway, look towards the center, and along this direction, this force, and 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 the object and object m mass object is orbiting by is rotating by the linear velocity v. Am I right?
Yes,
Then and radius here r, this radius, and from this picture and from this explanation we could write F equal to m v squared upon r. This is the formula, and there is a deduction, but not necessary to find out this, deduce this. Directly I have said F equal to m v squared upon r. And oh, centripetal acceleration, I showed you this in the video. Centripetal equation gives you linear velocity radius, then you can find out the centripetal acceleration. Or no?
yes, sir.
That means I have said acceleration, centripetal acceleration and centripetal
Force.
force. Two quantities I have said, and if you can remember this picture, and if you understand the each meaning of the symbol, I guess you could solve the mathematical problem, or could get the meaning of any creative question. Am I right?
Yes.
After the class, I may provide you some homework, okay, through your mother WhatsApp.
Okay, sir.
Without getting homework, you can't make you busy or else. Yeah. Look, here this I have said several times. V equal to omega r. Period and frequency I have said just now. Period and frequency I have said. Or revelation I have said. And examples of circular motion. Example of circular motion, you know, circle reference orbits. Orbits means, I don't know, orbits means
It's the orbit of the.
planet.
Yes.
Okay. Those are circular motion. Now this bent curve, I did not say this, and I am not interested to say about this because for understanding this I have to describe electrically or graphically and mathematically. Okay, next class I said anyway. Look, okay. Where is my slide? Okay, where is my slide? Where is my slide? Ah. Flat curves, not necessary. Vertical circles, not necessary. Minimum speed at top, energy, vertical motion, conical pendulum magnet, non-uniform motion, radial and tangential acceleration. Rotational kinetic energy, not necessary. Engineering uses. Engineer use a turbine. Have you heard the name of turbine? Hello?
Yep.
Hello?
Yes,
Have
sir.
the turbine, rotors,
Yes.
this engineer section. There you can see the application of circular motion. Now,
Yes.
this orbital velocity is necessary. This orbital velocity is necessary, and you have to understand in gravitational field section. In gravitational field chapter, we may understand orbital velocity. Understand?
Yes.
Orbital velocity, and I gave you first class or one class based on that chapter. That is gravitational field. Today I
Yes.
said circular motion. And, acceleration. What is acceleration? What is acceleration? Yield speed. These angles. Okay, fine. I've got it. I've got it. Angular acceleration. A slide view from the current slide. And centripetal acceleration and centripetal force. Okay, fine. Still I have said just now centripetal force formula and centripetal acceleration formula. I have just said just now, and this is the actually description and word writing. And look, what do you mean by centripetal acceleration? If an object moving in a circular path at a constant speed has a constant changing velocity. As oh my gosh, I said this first. Velocity has both magnitude and I said this. Therefore, the object must be accelerating. This is known as the centripetal acceleration. We know from Newton's first law that acceleration. Oh, I said this. Sorry, I said this. Newton's first law that no acceleration, an object must experience resultant force. Newton's first law. I showed you in the video. What did I show you? I show you if equal empty. I showed this, and both magnitude and direction object moving under therefore an object moving a circle must experience a force in this force, this force, centrifugal force, and centrifugal force Fc equal mv square over r. I said this in the video. I described this, and again I have repeated from this section. Okay, then we can find out actually acceleration repeating this, and here a is acceleration, m is mass, and it is the force. Okay, Ananya, and I could show you some question from where I can show you. I have forgotten where I kept here. Question. Topic not big. This is the question. Anyway, I will find out by searching. Actually, this nice picture of a bicycle. Okay, this is pedal. It's a question. I don't know. This is
Yes, sir.
question. Look, I showed you this picture, and this question came in 2025, and look here, said or asked, define the radian. Define the radian. Did I explain this radian in my lecture? Did I explain?
Radian. Yes.
Yeah, I said, what is radian? When the arc length is equal to the radius, then the angle is called radian.
Radian. Yes.
Or the ratio arc and radius constant, that is also radian. You can say according to view, whatever you understand you can explain, but main thing you have to keep same. Different radian. Due to radian, arc length and radius same. Am I right?
Yes.
Okay, fine. Yeah, this picture, and this question can look 9702, your code, your A2 physics code. What is the code? 97
9702.
9702, and it is 4242. 42 is a code. One is 41. 42 43. 43 enough. Okay.
Yes.
This is actually cool, and it's a variation for different countries. For different question pattern 41, 42, 43, and May, June. This question came in May, June. And you question in paper 4, A level structured question. Okay, and this is a candidate name. Have you ever seen? Okay, during the AS level, you could see this. And question paper, and it's marked 100. It's marked. Hello.
Yes, sir.
Mark 100. And time. Mark 100. Total mark 100.
Yes.
And time 2 hours. Time 2 hours. And paper 4, A level structured question. Okay, you must answer on the question paper. No additional materials are needed. Okay, instruction. And so all question use black same. Total mark 100, and there's a constant, and this is our question. Okay, and try to find out the answers. For radian, question mark 1, and rear wheel and the pedals of the bicycle are connected by a chain that passes around 2 cogs. Cogs means this cogs. Okay, this is big cogs and this small. Cog means bicycle pedaling portion.
Yes.
Two-tip wheels, you know, if you ever ride the bicycle, you know, I have a bicycle. This. Can you see my bicycle? Okay. Bicycle and shown the figure 1.1, and you look this figure, and there are some information which are like this. Rear wheel, and large cone this, and its radius 1.5 meter. This pedal, and this is chain, and it's a marked point. We have to consider this for doing our mathematics automatically. And this is small cog, radius 0.038 meter. This is small. Is it clear to you? Now,
Yes, sir.
now we will read the below section and try to understand what does the question mean, or what does the question want. And bicycle. Look, this bicycle is being pedaled so that it moves in a straight line at a constant speed, 17 meter per second. Understand? Question has provided as this number 17 meter per second is the small cog, this small cog, radius this, and is fixed the rear wheel. So the rear wheel, which one? This is rear wheel.
Yes.
Let me show you. This is rear wheel. Am I right?
Yes.
Okay. And now calculate the angular speed of rear wheel. Calculate the angular speed. Have you understood? And
Yes.
and for it, how much the mark? Oh my gosh, 2. That's why you have to do step by step. Since it's marked 2, and look here, radian per second unit has been provided. Angular speed, can you find out the angular speed? And uh, which angular speed we have to find out the angular speed of the rear wheel. That means which one rear wheels? This is rear.
Sir,
Sir, sir.
মাইকের সমস্যা হচ্ছে অনেক।
Okay, I'm going to complete. I'm going to finish. Just I wanna show this. Okay, understand?
Yes, sir.
Just this line I will complete. Then I will finish. Okay. That means angular speed. Your mic is problem.
No, sir, your mic.
Oh. Okay. Just 1 minute. Within 1 minute, we put to solve this. Angular speed
V by R.
V by R. Okay. Okay, that's all. Which one is V?
17.
17. And which one is R?
0.46.
0. Okay, Anurna, that's all today. And try to solve such types of problem which came in various year. You try to solve. And I have given this problem as a homework. That's all today.
Okay, thank you, sir.
Okay. Anurna, have you any
Yes?
question? Do you
No,
want
sir.
No question.
No, sir.
Why?
Sir, I understood, sir.
You understood. No problem.
No, sir.
Okay. You will do this mathematics, the key question, and submit through your mom WhatsApp or your WhatsApp. Can you solve this?
Yes, sir.
Okay, that's all today. Assalamu alaikum.